What's up, guys? My name is Performance. Today we're going to go through a bit of a video on engine blueprinting, the idea of it, what it is involved, various different bits and pieces, and why it's absolutely necessary to make a successful rebuilt engine. Not necessarily performance, or just in general. It's always good practice to be doing all your critical measurements, and that's basically ultimately what engine blueprinting is. It's measuring. It's quite an in-depth period of part of work. So we'll go forward with what we've got here on display here. We'll just identify the various different bits and pieces, and then we'll go into more depth. So top right hand corner, we've got a stretch gauge. We'll use stretch gauge for when we're setting rod bolts. We'll measure the static length. We'll then zero the gauge. So obviously that involves turning the gauge to zero. That's its static length. And then we start applying torque. We go up in stages until we get the desired amount of stretch. Obviously the rod bolt will stretch because we're applying torque to it and it grows. So I mean, I think ARP, they 5.5 to 6 thou, I think, for the ARP 2000 bolts. So you would see that on the dial indicator. So that's just a very different. That's the purpose of that. Stainless steel rule does what it says. Then we've got, it's a bit of a homemade job. Used to find TDC on engines. This is a tool that I made. It stops you basically having to find the various different bits and pieces, timing marks on the crank or on the pulley. And 9 times out of 10, the factory marks are never 100% accurate. So with this, you get accuracy 100% time. It's basically, you'll get, screw this into the spark plug, obviously take spark plug out, screw this into spark plug and rotate the engine over until it actually, it starts to stroke out, it zeros and then starts to go back the way. That's your TDC finder. Basically just a spring with a rod on it with a DTI at the very top of it. Okay. So we'll find top dead center, true top dead center with that. Then obviously we've got our bore gauge. We will use this for various different steps in the game. We'll measure bore. What it will tell us is obviously the dimensions, the internal dimensions of that cylinder bore. It will also tell us if the bore is tapered, any egg shape to it, ovality or whatnot. But we'll also use this for the mains and the big ends for calculating our oil clearances. Don't just take it as gospel what the manufacturer says. This is where you need to do your homework. So again, this is basically just a bore gauge with a digital DTI on them, and you've got a probe in there, and obviously probe goes in and out, and you've got various different prongs to go on the end of there, various different sizes. We've got another one here. I'll use that one for the cylinders, and then I'll use this one for the mains. There are more versions or various different lengths of these in the kit, but those are the ones that I typically use most of all. So that's the bore gauge. Then obviously we've got external mics here. They do what they exactly say on the tin, and we've got the setting gauges for that. Before you ever use, you then set 25mm, so you set the gauge and make sure it reads 25mm there. This is basically just setting your mic. You always do this before you use the mic. It's good practice, and it will always guarantee you accuracy every single time. Below that, we will use this to make sure that the pistons they're all square across the board. So you've got, say for example, if you want to measure if you had a bent con rod, for example, you've been doing some heavy boosting or whatever, or it's a stock engine, we will typically measure any bend in the rod with this. Again, it's just a machined piece of brass with a DTI on top, and you'll set this on the deck perfectly flat, and you'll rotate the engine over, and as the piston comes up, it touches that, zero the mic, or as the piston starts to go all the way up, and then just as it starts to come down, then you zero the mic, and then you check all the other pistons to make sure that they're all the same. Also tells you if you've got problems with your big ends, or there's an actual problem with the crank or whatnot. It's a very useful piece of kit. I typically use this on every single engine build that we do. So there's that. Again, this is all homemade tools. I don't really I'm not really flush enough to buy the expensive kit. And 9 times out of 10 it comes from America, so you get raped by the American taxman, then you get raped by the UK taxman. So there you go. Then we got this. It's basically just a vise for a vise. We'll use this to set the big ends in our in the con rods. We'll use this to stretch and cycle the stretch of the rod bolts. So basically, your big end will go in there. That's gripped in the vise. It just grips the big end in a more convenient manner. It's phosphorus bronze, so it's nice and soft. It won't damage the con rod itself. And again, we'll use the stretch gauge, find the static lengths, measure them, and then perform our stretch to the required length. So that's one of those. And then moving on, we've got the piston ring compressors. You get the shitty little, I'll see if I've got one. Everybody's bought one and has regretted buying one. They're cheap, and they're cheap for a reason. This fucking, I don't know what to describe this. It's just a piece of flexible tin with a spring on it. They're fucking hopeless. They really are. Avoid using these at all, especially on the VR blocks. They don't work with the VR blocks. So, the various different other, I've got other piston ring compressors somewhere else. That's our VR one because it's chopped, and we obviously have we had this made. Obviously, it's a bit overkill, but it was just with the material that they had lying about. You've got the orientation mark, which we will use, and obviously you can see it's chopped. Nice machine grip marks, and you can actually see how much it's been chopped. That's to do with the degree of the V in the VR6s. That's from an ABV, I think it was, or AAA, I can't remember. And then you've got another one underneath, what's that, 82.5, and then you've got 83mm below that. Then we've got our V-blocks with bearings. We will use that to sit the crankshaft on it, and we'll rotate the crankshaft to make sure run out, make sure the crank's not damaged, not bent, and we can use a DTI. We've got a DTI in one of the cupboards up here, and it basically just tells us the general condition of the crankshaft. You know, if you've bought a second-hand crankshaft, the first thing I'd want to do before you measure any of the run out is to make sure that it's still straight and true. You know, especially if it's been delivered by certain shipping companies. We're not going to go into that, but there you go. Above that, should I say, digital calipers. We will use these for quick references. Typically, probably just to confirm the blade of a feeler gauge. They're very untrustworthy, but for a quick reference, they're not bad. They get what you pay for. Even the Mitty Moyo ones are questionable at best. If you really want to get an accurate reading of its critical, you know, mission critical component, you will use the external mics there. Torque wrenches, 1/2 inch, 3/8. Don't use them as golf clubs. We don't even use these for breaking off big bolts. We only use these strictly for torquing. A right hand thread, that is. Just to quarantine it, we know it's in good condition. Above that, this is for the 2 litre TFSIs. This is for locking out the crankshafts at TDC. I can't remember what it is. It's between cylinders 3 and 4, I think. And that will go, the camshafts have got a little slot in them. Basically, when they rotate, it allows you to drop this down, and then you bolt it down to the top of the cam bridge, and that allows you to set the cams to top dead center. Allows you to start backing off the cam pulleys and whatnot. Cheap and nasty magnifying glass. This one's probably got an LED under it. Branches probably don't work. Oh yeah, they do. So yeah, we'll use that to inspect just whatever we need to inspect. You know, typically the block deck and stuff like that. You know, if it's a lot of these VR blocks, oh, that's fucking useless. A lot of these VR blocks are getting quite old. The coolant's not being looked after properly in the engines, so you get a lot of corrosion build up. So we'll look at that to see if the heads are porous. There you go, that's better. Then beside that, this is specifically for the CEPA, so my 2.5 litre 5-cylinder TFSI engine we'll use to set the oil pumps. The oil pump is basically got 3 magnets. Well, the gauge has 3 magnets, pulls the pump to a calibrated length from the bottom crankshaft pulley. It's basically to make sure that the chain is running around these two pulleys concentric to each other and parallel. And it's not going to wear the chain out, not going to wear the pulleys out, and not going to snap the chain. So that's an alignment tool specific to that engine. The problem with the bad cars is that there's a lot of specific tooling that you need for it. I've sampled some of the stuff you get off of eBay, and 9 times out of 10 you throw it in the bin, and I just buy the genuine stuff because I know it works. And if you've spent a fortune on building the engine, what is another £100 to guarantee success in that build? It's peanuts, really. Cylinder head stands, they are what they say I'm like. Magnetic tray, quick reference guide. This is basically for various different bolts. A lot of the ARP stuff from America is obviously imperial, so we then obviously have an imperial gauge and a metric gauge comparison. Then we've got a thread gauge on the back of that. Nice and handy, got that a long time ago. It's very useful to have. Temperature gauge, humidity gauge, we will use that obviously when we're building an engine and we get the room up to temperature of 20 degrees. We give it about a weekend to basically all the metal settles out, all the thermal expansions settle out. More critically, the measuring components and whatever it is you're measuring are both at the same temperature. Basically, it means it's professional, and it's the way it should be done. Whenever you're measuring stuff, you need to measure it at the same temperature, because metal expands at various different temperatures, it contracts at various different temperatures. So if you want to be a consistent engine builder, well, for successful engine builders, should I say, temperature gauge is just as important as calibrated measuring equipment. Then moving on, we have the, this is for setting and unsetting the cam chains on the 2.5 TFSIs, the CEPA engine, same engine that's in my meth machine, the RS3, goes with that tool there. That's obviously for the oil pump. This is for the cam chains, so that will go on the actual cam chain variable valve timing pulleys. That will lock out the cams. The cams at, like, say for example 12 o'clock, have a machine flat with an M8 metric threaded hole. When both cams are both at top dead center, the flats will line up perfectly, and then you just secure it. It's just mild steel, it's a grade 8.8, so you're not really using the strength of these bolts, you're using the face there to make sure that the cams are set correctly. When you come to take the chains off or put the chains on, you kind of hold the cam pulley with that, with the torque range. I think it's like a 24mm, apply 50 newton meters of torque in one direction to counter torque the counter torque the pulley as you apply torque in the direction of the thread to lock it out. That is basically for turning the crankshaft pulley, or the damper pulley should I say. There isn't just a bolt you can just stick a socket on like the 2 litre TFSIs or the 1820 valves. You physically need to have this. I've modified it just because I found it easier to use, a bit of a better design. And that is obviously for locking out the crankshaft. There's a small, it's an M12 or M14, I can't remember the size of it, on the side of the block, and there's a machined dome on one of the counterweights of the crankshaft. You just screw that into through the side of the block, and it mates into the dome, the female dome of the counterweight of that crankshaft, and it confirms that the crankshaft is set at top dead center and it is locked in place, which allows you to do your various different checks you need to do for your timing chains. So we talked briefly about measuring equipment. A lot of stuff we will double check oil clearances using plastic gauge over here. So plastic gauge is basically just plasticine. It's calibrated lengths of plasticine, various different lengths, thicknesses. You will place that across the journal bearing, whether it's the mains or the big ends, and then you have a calibrated measuring stick. Basically you measure the squash. So you go through your standard procedure. If it's studs, you torque them to the correct torque. If it's rod bolts, you'll stretch them to the correct stretch. You then release that's the bearing cap, bearing saddle, depending on your preference, and then you measure the squash, and that will tell you your oil clearance. And that should always come back to what you determine between the outside diameter of your crankshaft, the internal diameter of the crankshaft bearings or the big end bearings, and that should always come back to the same. So when you're measuring from one direction, you're also measuring back, and the numbers should always should match up. If they don't, something's wrong. Measure again. Measure, measure, measure. You only get one chance at getting these engines right. Feeler gauges, again, you will use these for I just use them for basically checking my ring gaps. Which brings us onto this little toy here. Again, homemade. I don't buy the expensive stuff. I just prefer to make it myself. This is just a ring gap. Stick it in the vise here. So you stick it in the vise like that. Set your ring gap. You only grind one side of the rings. I've seen some people grinding both sides of the rings. I wouldn't advise on that. You always grind one side of the ring, because the other side, the opposite side, has been machined perfectly straight. So you can use that as a datum point to make sure when your rings are pinching up to the gap, you've got a nice parallel gap. You don't got a taper going on there, because obviously that's not a true ring gap. And again, push it up against there, spin, spin, spin. We do it nice and slowly because it's very difficult to add material. It's easy to remove it, but again, very difficult to put it back. Spark plug gauge. We will use this obviously to set spark plugs. A lot of the stuff now is all iridium. The Denso or YKG, what's the other one? Champion is another one. There's various different makes out there. NGK, should I say. NGK is quite a popular one by choice. They've come pretty well gapped, but I think typically it's 0.75 to 0.8 of millimeters. Then you've got fuel injector pullers. So again, sometimes depending on the age or the mileage of the car, the injectors can be a bit stubborn to come out. Sometimes the injector comes out with a fuel rail and the whole injector comes out, or the fuel rail comes off and the injector is left in the head. So we've got the proper VAG pulling kit. So if that's stuck in the head, you've basically got to strip this down. This is just a puller. So that will sit in the cylinder head like that. Slots in from underneath. Puller goes in, tighten up the bolt, and it pulls the actual injector out of the head. Just for stubborn. I've never actually had to use this yet. So again, that's just a puller for the injector. Then obviously, because these are direct injection engines, they use a Teflon seal. You cannot reuse this. I can't stress this enough. The amount of times I've seen people reuse this and then it melts and the combustion gases just set fire to the Teflon seal. And then you've got combustion gases leaking past here, superheating the injector, and you've got 130 bar of pressure going through that. You know, even more if you've got an uprated high pressure fuel pump. Not a good idea. So you cut off the old Teflon seals. You get the new Teflon seal. Now the new Teflon seals are bigger than the actual stalk of the injector, and you have to squash it back down onto it. With the proper VAG tools, I've seen some guys using a biro pen lid, whatever works for you, but I tend to use the when it comes to fueling and the sheer amount of labour that's involved, and to remove all of this to put it on properly, it's just not worth it. So I've got the genuine the stalk injector kit. You will slide the Teflon seal over that to get it over the face of the injector and locate it over the groove. There will be a groove. This is an old injector. Then you've got various different no-go gauges that will press and squash the Teflon seal onto that injector. And then the final one is basically when you push it in the head. So that's the injector. When you're skimming decks of blocks or skimming heads, you'll always get burrs. Remove those burrs. You don't want them snapping off or floating about in the engine bay. It's never a good thing. And it's sharp, and it's not nice to handle. A sharp, razor sharp edge on a cylinder head, and it could potentially damage your gasket as well as cut your monkeys. So we use this for setting the VRs. Well, specifically it was a 12 valve VR, which is one's got the recess on it, because you've obviously got one camshaft slightly longer than the other. 24 valve ones are a little bit different. This we'll use to set the cams on the top dead center. Then we've got Teflon expanders. Basically, this is just for the crank main seals. It allows a seamless transition going from the guide onto and past the lip of the crankshaft, and then you hammer it into position on the flange, and that prevents oil leaks at the rear of the crank or the front of the crank. Then you've got various different locking pins here for, you know, when we'll use the tensioners. When we're adjusting tension, or removing chain tension, should I say, we then lock off various different chain tensioners with this. Okay, so I mean that's a very brief I hope it was brief. I know I can waffle a little bit, but hopefully that gives you a bit of an insight into engine blueprinting, various different components that you will need. So yeah, if you need anything else, guys, if you've got any recommendations, comments, or questions, feel free to fire them below, and hopefully you've taken something from this. Cheers.